Kia ora tātou. I've been invited here by Ngāia to introduce a project that I'm working on. It's understanding braided rivers in the subsurface. Braided rivers are a special type of river, and they're quite unique to New Zealand. And they're rivers that formed in a very highly active environment. And so they're quite unusual in the world. So it's important for us to try and understand them here, rather than rely on people overseas. So I'm leading this project, and I'm from an organisation called Lincoln Agritech, which is a research organisation that's part of Lincoln University. And this project is a 5-year program, and it's an MB-funded program, and it's part of the MB contestable fund that they have each year, and they grant projects for up to 5 years. So we're about 1.5 years into the project now, so it's quite new. There's quite a few of us involved. So as I said, I'm with Lincoln Agritech. We've also got a big component from NIWA. This sort of environment to research, it requires a lot of different knowledge, and I'm guilty of being an ologist, so I'm a geologist and a hydrologist, but there's lots of other ologists involved in the program. So we've got some specialist river people from NIWA, and some people from the University of Canterbury, a few people from overseas, Flinders University in Adelaide, TED in Dresden in Germany, and Aarhus University in Denmark, and also Lincoln University, and of course Nayo and Shade from Ngāti Kapanunu. So there's a lot of different knowledge which is brought together in this program. So I have a few research questions, and our program is primarily about understanding how these sorts of rivers work underneath, how they work in the subsurface. And there's a lot of modelling of these types of rivers which is done to inform policy decisions at the regional council level. But I have to say that these models don't actually represent these rivers particularly well, because we don't really understand how they work. So if we can understand how they work, then we're in a position to actually be able to model them. So there's a question about how much water goes where, and quantification. If we can understand how they work, then we might be in a position to understand what components go where in that hydrological system. So there's different parts to that. There's water that's stored in the gravels just underneath the river, and that helps the river to flow during the dry season. There's also a certain amount of water that leaves the river and goes back into the river nearby. And there's a large component of water which is very important for groundwater recharge. So water leaves the river and it leaks downwards and recharges the aquifers. And this provides the flow for the springs that you find on the plains. So if we can understand all of these things, how they work, then we might be able to manage them a little bit better. And one thing I'm wondering, a key question for me, is how does some of the management that we're doing now, not just about the river and the flows in the river, but also in the river environment, the flood engineering, the gravel extraction and so on, how do those sorts of activities affect this balance of all of those different parts of the water? The storage, the proportional flow that enters and leaves, the flow during the summer. How do all these activities affect those parts of the water balance? Once we can do that, we can understand how our activities are affecting the river and all the different components related to it. Then we're in a position to do some scenario testing and look at economic implications and other implications of the way we're managing the river. So it's an approach where we're trying to see the river as a bigger resource rather than just what you see on the surface. And related to this is we've had over 100 years of flood management. So there's been an approach by the regional councils to get rid of water, to remove it from the catchment. And there's a question I have is, what kind of impact does that actually have on the river in the dry season? What kind of impact does that have on groundwater recharge? and also what are the potential benefits of restoring some of these rivers. So there's 3 rivers that we're studying in this program. We're looking at the Southern Waikirikiri, which is where I'm from, down in Canterbury, the Wairoa River in Marlborough, and here we're studying the Ngātaroa River. And we're studying parts of the river where most of the losses to groundwater are occurring, where the groundwater recharge is occurring. So in the Ngātaroa, it's between Royce Hill and Fern Hill. And so the river at this stretch has a mean flow of about 40 cubics. That's quite a lot of water. But it's losing about 10% of that water over this reach. It's got a width of about 300 metres, 2 to 5 braids, and it's a depositional reach. What that means is that there's a lot of gravel that's brought down from the hills and dumped in this particular area. And that's one of the reasons why there's so much loss to groundwater here. But because of that gravel that's being dumped in this area, there's also a huge amount of gravel extraction. So that's a view from the river from above. And you can see the activity of some of that gravel extraction down there in the distance. In the foreground, the river is quite nicely braided, but as you head downstream, it starts to become channelized. So there's a question about what that does to the water balance. This is a water level plot. So the council shows a lot of these sorts of plots. And what it is, it's the groundwater level on the left-hand side here. And we've got time, these are years, on the bottom there. And that's a long-term monitoring well that the council has at the substation, which I think is near Maxmere. And you can see that since monitoring started in 1969, there's a pretty large decline in groundwater levels. And that decline is going to be manifest in a lowering of the spring flows on the plains. So there's been quite a lot of work. We came up and did a campaign recently with NIWA, and they did a whole lot of measurements of flow on the river. It's quite difficult to do because you have to measure every single little channel and add all those up to see what the flow is at that point. So we're measuring flow at different points in the river, and we're trying to get an idea of how much water is losing out of the river as you go downstream. And one of the things you have to do this is you have to actually correct the flows for the fact that there's a time lag between the sites. So it takes time for water to flow from here to here, and during that time the river flow can be falling or it can be rising. So you have to make all of those corrections, and this sort of shows the result here, and we're sort of losing less water, like this is about 45, 46 cubics, whereas down at the Fernhill Bridge it's about 43. So we seem to be losing less water now than what we used to in the past, at least from this one survey. It's showing that we're losing less water than what's been reported in previous studies. Previously they were saying 4.5, 5 cubics. So we're probably losing about half of that, just according to this one survey that we've done. So we need to do a lot more of these, and we will do in the next couple of years. This is just an image to see what the river used to look like. So this is an aerial photo from, I think it's 1964. And what I've done is I've drawn the current edges of the river in blue there. And it's quite remarkable how much the river has been trained by the river engineers. It's probably about half the size as what it used to be now than what it was back in 1964. And you can see there's quite a lot of habitat that's been lost on the margins. This photo and another one, which I think is on the next slide, these two photos are on the poster on the back here, which Noah's put up. So this is the same plot, but what I've done is I've taken the 1964 river margins and plotted it on the present day photo. So you can see that kind of training of the river, even thinking about it logically, it must have had some impact on the hydrology. And I guess one of the things also is you've got a lot of gravel extraction going on now that wasn't happening in 1964. And something you can't see in this photo is that the bed of the river has actually dropped quite a lot because of that gravel extraction. So this is what the gravel extraction looks like. These are cubic metres per year, and you can see that it's been increasing over time, probably reached a plateau of about 300,000 cubic metres of gravel per year. So that's a lot of gravel. I think one Olympic-sized swimming pool is 1,000 cubic metres. So you're looking at maybe 300 Olympic-sized swimming pools a year of gravel. And most of that gravel is coming out of the reach that we're studying between Roysville and Fernville, which is in here. In terms of the way we think the system works, what we've done is we've drilled a whole lot of drill holes. You might have seen some little red poles sticking up out of the ground. We had a drilling rig and we put some drill holes in, these red dots here, to measure the water level and the temperature of the water as well. These are a couple of council monitoring wells here, the blue ones, that have been there for a while. The water is known to leave the river here and flow in this direction towards Blackpool Hastings. Most of the water is probably going to leave the river in this section here, and it's going to decrease as we head downstream. So I'm just going to show you a couple of water level plots from this site and this site. Again, the long-term council records, just so you can see what's been happening over time. So this is Fraser number 4, which is this well here. And you can see that that one's been declining quite a lot. So we've got water level on the left, time since 1991 to the present. And groundwater levels there have probably dropped in the order of 1.5 meters, roughly. And similarly at the other well that I pointed out there. So you've got a decline of about 9 centimetres a year, something like that, since 1992. I think one of the things to notice in this plot was that there was that managed aquifer recharge site, which you can kind of see in here. That's what this structure here is. So for about a 20-year period, water was taken from the river and routed down a canal and leaked into the aquifer here to try and improve the recharge to the groundwater system. And it was closed down because it supposedly didn't have much of a benefit, but you can actually see on this plot where it stopped. You can see that water levels are reasonably stable, and then they start to decline once that system is shut down. So it certainly was having a benefit. One of the reasons I wanted to show these two plots is that these two wells are in the recharge part of the aquifer. And so they're right next to the river, they're receiving water constantly. And if we're seeing groundwater levels declining in this particular area, some of it's going to be due to groundwater pumping, but the majority of it's going to be due to the fact that there's something happening in the river, which means there's less water coming out of the river to recharge the aquifer in that area. And that's one of the reasons for this study, is to try and understand what is it that we're doing to the river that's changing. So we're doing quite a lot of work. NIWA have brought a big team up here, and we've done a helicopter survey over the river. It's interesting, we normally do this with a drone, but you're not allowed to fly drones above the river because it's an Euroclub flight zone. So we ended up hiring a helicopter and taking photographs out of the window of the helicopter. And we've done a LiDAR bathymetry survey, which is shown up here, plus a whole lot of flow measurements. So that's some of the work that's been happening above the ground in the river. We've also been looking under the ground. This is a bit of equipment that was brought over from Denmark to do surveys of what's under the ground using electric current. So you put an electric current through the earth and you measure the response in terms of its electrical conductivity. And we can use that to map out what a subsurface looks like. We've been doing drilling, as I said, and looking at some of the material that's coming out of the drill holes, which is what's shown here on the right-hand side. that's it for me, and I'll probably have some talk with you later on, and no doubt some of you will have some questions about the program. I'm interested to hear some of your experiences of the river and how things have changed over time. This is a 5-year program, and we've only really just started. In terms of the process, the first part of the program is about trying to get some understanding about what's actually there. So we put in some instrumentation, we measure things. The next part is we try and understand that through analysis of the data that we're collecting, and we do some modelling. And then the third part is where we try and use all of that analysis, understanding and modelling to understand what happens if we change this in the river, and what happens if we change that in the river. And then we can start to inform some decision making from that point. So that's it for me. Kia ora.